Day 514 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1039, minimum score triangulation of Polygon. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You have a convex n-sided polygon where each vertex has an integer value. You are given an integer array values where values of I is the value of the ith vertex in clockwise order. Polygon triangulation is the process where you divide a polygon into a set of triangles and the vertices of each triangle must also be vertices of the original polygon. Note that no other shapes other than triangles are allowed in the division. This process will result in n-2 triangles. You will triangulate the polygon for each triangle. The weight of the triangle is the product of the values at its vertices. The total score of the triangulation is the sum of these weights over n-2 triangles. Return the minimum possible score that you can achieve with some triangulation of the polygon. All right, y'all, so I can understand how that may be a little bit difficult to understand. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. Now, before we get started in the examples, let's go over what a polygon is. So a polygon is a flat closed shape made up of straight line segments that connect end to end in a loop, meaning it's going to be closed, which means all of the sides join so there are no gaps. Or these are some key features, I should say, of a polygon, meaning that, or one of these key features is it's closed and all sides join so there's no gaps. Another feature is it's straight edges, so there will be no curves. Each side will be a straight line. And the last key feature is it has at least 3 sides. So the simplest polygon is a triangle, but a polygon could be many different shapes. It could be a pentagon, could be an octagon, could be a hexagon, could be a triangle. So we want to take these shapes. Say we have a octagon, for example. We want to take the octagon and we want to see how many triangles we can fit inside of those octagon, and then each triangle is going to have a weight and a score, and we want to find the minimum score. So let's take a look at these examples just to make sure we're doing this problem correctly. Let's take a look at example 1. So in example 1, we have our input values equals an array of integers 1, 2, 3. So as you can see, each one of these elements represents a side of the polygon. So since there's only 3 elements, we know we're already dealing with a triangle. So we don't have to split it up into smaller triangles. We're starting with a triangle. So that's all we need is that one triangle. It's one triangle. It's not an octagon or a hexagon where we could split it up into more triangles. We're starting with a triangle. And since we're starting with a triangle, we just need to find a weight and the score of one triangle, right? So the weight of the triangle is the product of the values at its vertices. So the product of the value of its vertices would be 1 times 2, which is 2, and then 2 times 3 gives us 6, right? So then we have the weight, but we want the score. So the total score of the triangulation is the sum of these weights. So since there's only one triangle, that means there's only one weight, and then that weight has a weight of 6. And so since there's only one weight, that means the score will be 6 as well, and that's why the output is 6. The explanation says the polygon is already triangulated because it's already a triangle, and the score of the only triangle is 6. So we don't have to add up any other scores or find the sum of any weights because there's only one weight, which is 6, and that's why the output is 6. So let's take a look at example 2 where it's a little bit more tricky. We have more sides in our polygon, and we have more triangles that can be formed. So in example 2, we have our input values equals an array of integers 3, 7, 4, and 5. So that represents the vertices of our polygon. It says the output is 144. So let's see how they got that output. So Explanation says there are two triangles. So remember, it says right here that the process will result in n minus 2 triangles. So since we have 4 elements, then n minus 2 is 2. So we know that we're going to have 2 triangles just off the fact that n equals 4. So now we have to find those 2 triangles, and that's what, if you missed yesterday's problem and the day before problem, so day 512 and day 513, I suggest y'all check those out, because those are sort of prerequisites to this problem, and it deals with how you find the triangles in an array, how we find the sides of a triangle in the array. So once again, with the triangles, it should be all of these must hold true. Side A plus side B must be greater than C. Side B, or side A, sorry, side A plus side C must be greater than B. And side B plus side C must be greater than A. So these are the rules of a triangle, right? And as you can see, let's look at the explanation. There are two triangles with possible scores. So let's look at the two triangles. So we have two triangulations that we could do, and each triangulation has two triangles. So the first triangulation we could use these two triangles right here, which would give us when we add it all together. Or actually, I want to show y'all how we know it's a triangle first. So let's say we take these two triangles, 3, 7, and 5. We know this is a triangle because 3 plus 7 is greater than 5, 5 plus 7 is greater than 3, and 3 plus 5 is greater than 7. So we know that's a triangle. Similarly, with this next triangle, 4, 5, and 7, we know that's a triangle because 4 plus 5 is greater than 7, 7 plus 5 is greater than 4, and 4 plus 7 is greater than 5. So all of these requirements hold true, so we know we're dealing with a triangle. But now we're not done yet, because that's just so we understand that we have a triangle. But that's not what we want. We want the weight and the score. So it says for each triangle, the weight of that triangle is the product of its values at its vertices. So we want to do 3 times 7 times 5. So 3 times 7 times 5 is going to get us 105. So let's just say 3 times 7 times 5, that equals 105. Boom. Then that is going to get us the weight. So once again, the weight of the triangle is the product of its values at its vertices. So that's the weight of the first triangle. Then we have another triangle, 4, 5, and 7. So to find the weight of that, we could do 4 times 5 times 7. That's going to give us 140. So let's say 4 times 5 times 7 is going to equal 140. Boom. Then when we add those two together, we get 245. Boom. That's where this comes from. Then we would do the same thing for this. And I'm not going to type it out for y'all, but in the end, when we add when we add this, remember we're doing PEMDAS, so when we add this plus this, we're going to get 144. So let's just say we have 144. Boom, 144 is less. We get rid of this because that's all we're worried about. 144 is less than 245. Remember, we want the minimum possible score. So that's why our output is 144. That's how we got 144, because we found the triangles that we can create with this array, and then we multiplied the sides of those triangles, and we found we multiplied the sides of those triangles times, and then we added those. So we multiplied the side of one triangle, added that to the multiplied side or the multiplied sides of the next triangle, and whichever one is smaller, that's the one we return. That's how we got 144. So let's take a look at example 2 just in case, or example 3 just in case that didn't make sense. So in example 3, we have our values 1, 3, 1, 4, 1, and 5. Our output is 13. The explanation says the minimum score triangulation is 1 times 1 times 3 plus 1 times 1 times 4 plus 1 times 1 plus times 5 plus 1 times 1 times 1, which gives us 13. That's how we got the output 13. So in this case, you can see n minus 2. So in this case, n equals 6. N minus 2, we should have 4 triangles. And then those 4 triangles are right here. This is a triangle. This is a triangle. This is a triangle. And this is a triangle. And I hope that makes sense to y'all. And now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is definitely easier to understand than the question, so let's get into it. Now, the first thing we want to do is we want to create a 2D memoization table to store the minimum score of subproblems. So memo of I and J represent the minimum triangulation score for the polygon section from vertex I to vertex J. So we're just going to come right here, declare a variable called memo. We're going to set that equal to an array, open up the parentheses, repeating. It's going to be a 2D array, so it's going to be repeating another array. We're going to open up the parentheses on that. We'll say repeating again. This time we're going to say colon -1, comma, count, colon, values dot count. And come outside of this parentheses, we're going to say comma, count, colon, values dot count again. Boom. Then we need a recursive helper function that returns the minimum score to triangulate the sub-polygon between indices I and J. So we're going to come underneath this. We're going to create our helper function. We're going to say func. We call it helper. Open up the parentheses. We're going to say underscore array, colon. It's going to be an array of integers. Come outside of that, we're going to say comma, underscore I, colon, that's going to be an integer, comma, we can say underscore J, colon, that's going to be an integer. Come outside the parentheses and we're going to return an integer like that, and then we're going to open up the brackets. Then we're going to create a base case. If the sub-polygon has fewer than 2 edges, then that means no triangle can be formed, so the score is 0. So we're going to say if I is greater than or equal to J, we're going to open up the brackets and we're just going to return 0. Then we're going to start the largest possible value so we can look for the minimum. So come underneath this if, we're going to create a variable called min score, and we're going to set that equal to int dot max. Once again, we're starting from the largest possible value so we can look for the minimum. Boom. Then we are going to come underneath this right here, and we are going to say we're going to try every possible vertex K between I and J as the middle point of the triangle. So we'll say for K in I less than sign, open up the parentheses and pass in J. We're going to come outside of that. We're going to open up the brackets. Boom. And we're going to recursively compute the minimum score for the left sub-polygon, which will be I through K, the minimum score for the right sub-polygon, which will be K plus 1 through J, and then plus the score of the triangle formed by the vertices I minus 1, K, and J. So we're going to say let temp equal helper, open under parentheses, array, comma I, comma K. Come outside of those parentheses, we'll say plus. We come underneath that just to make it a little cleaner. We'll say helper, open up the parentheses, array, comma K plus 1, comma J. Come right here, we're going to say plus. Then we're going to open up the parentheses, we're going to say array, square bracket I, minus 1. Come outside the square bracket, we're going to say times, array, square bracket K. Come outside of that, we're going to say times, array, square bracket J. Boom. Now we need to keep track of the smallest total score by coming underneath this and we are going to say if temp is less than min score, then we are going to open up the brackets and we're going to say min score equals min, open up the parentheses, min score, comma, temp. Then we need to store the current best in the memo table by coming underneath this. And we're going to say memo, square bracket I, square bracket J equals min score. Boom. Then we need to return the cast result for this range by coming right here. And we're just going to say return. Sorry, y'all. Return memo, square bracket I, square bracket J. And then we just need to return the score, our final output, by coming right here. Or excuse me, return the minimum score by coming right here. We just call a helper function by saying return helper, open up the parentheses, values, comma, 1, comma, values dot count minus 1. That should be all that she wrote, y'all. Let's give it a run. See how it runs. It's accepted. Let's submit it. Make sure it's still accepted after we submit it. Let's see. Oh, time limit exceeded. So let's see where we went wrong. So give me a moment, y'all, while I try to figure out where we went wrong. Oh, I think I see it, y'all. So right here, we missed a step right here, or I missed a step right here. Sorry about that. But if we've already computed this subproblem, we need to return it to avoid redundant calculations. So we come right here, we'll say if memo, square bracket I, square bracket J, sorry y'all, square bracket I, square bracket J does not equal -1, then we're going to open up the brackets and we are going to say return memo, square bracket I, square bracket J. Now that should work. Now let's go ahead and submit it. Make sure it still works, or make sure that's what was messed up. Okay, so that should only have one square bracket. I don't know where the other one came from, but let's submit it anyway. Let's see. Okay, so, oh my goodness, y'all. I don't know what's going on. All right, so that should fix it. Let's see. Let's see, it's accepted, y'all. That's what I'm talking about. 3 millisecond speeds dash % of users. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.